This video is for Homework and Mastery 1.9, Section 5.6 in your textbook, Solving Applied Problems Involving Fractions. What we're going to be looking at here is working with word problems, applied problems, that have fractions within them. We're also looking at how to solve them. We want to look at the specific steps that we take in order to solve these. We want to think about it and walk through it rationally. We're going to use a method called the mathematical blueprint. So you'll want to write down the steps that we go through for this mathematical blueprint. So let's take a look at an example. Jason planted a rectangular rose garden in the center of his 28-foot by 22-foot backyard. Around the garden there is a sidewalk that is 3.5 feet wide. The garden and sidewalk take up the entire 28-foot by 22-foot yard. What are the dimensions of the rose garden? First of all, we need to sit here and think about what this is even saying. We want to stop and gather our information that we have and look at what we know. We know that there's a rectangular rose garden in the center of the yard. The yard is 28 feet by 22 feet. There's a sidewalk that is 3.5 feet wide all the way around the garden. And the garden and the sidewalk take up the entire backyard. What we've just done is we've gathered some facts, and we're going to draw a diagram to look at these using the dimensions. What we need to do also is we need what we're being asked to do, which is step 2 of our mathematical blueprint, is find the dimensions of the rose garden. So step 1 in a mathematical blueprint is to gather your facts. Gather what information you know. Step 2 is to decide what you are being asked to do. What is the question actually asking for? Step 3 is to ask yourself, how do you proceed? What do you actually need to do in this process? So what we need to do is we need to find the length and the width of the garden. Step 4 is to find the key points to remember. What we need to remember about this is that the garden is in the center of the yard. This is important because we know that all the way around the garden has the same amount of sidewalk. So wherever we look and we draw the picture, here's a picture that I've drawn. We know that the yard is 28 feet by 22 feet. We know that there's a sidewalk 3.5 feet on all the sides. Same width. So the length of the garden is going to be the length of the yard minus the width of the sidewalk. We have to remember that it's actually twice the width of the sidewalk because we have one width of the sidewalk here and one width of the sidewalk here. So that's why I said the left plus the right side of the sidewalk. So the length of our garden will be equal to the length of the yard minus the entire width of the sidewalk, which will be the left side plus the right side. So the length of my garden will be equal to 28 feet minus 3.5 feet plus 3.5 feet. I got that 3.5 feet plus 3.5 feet because there's 3.5 feet here and there's 3.5 feet here. I add 3.5 feet plus 3.5 feet and I get 7 feet. So I have 28 feet minus 7 feet, which is 21 feet. So the length of my garden is 21 feet. Now I need to do the same type of process with the width of my garden. So I look at the width of my garden and I know that it's the width of my yard minus the width of the sidewalk, which again, that's the above amount and the below amount. Remember, the width of the yard was 22 feet, and each width of the sidewalk is 3.5 feet. So I'm going to take 22 feet minus the two widths of the sidewalk added together, which is 3.5 feet, plus 3.5 feet. When I add 3.5 feet plus 3.5 feet, I get 7 feet. So I now have 22 feet minus 7 feet, which gives me 15 feet. So the dimensions of my garden are 21 feet by 15 feet. So we've figured out our dimensions of the garden by subtracting our original length and width of our yard and taken that amount and subtracted our width of our sidewalk. And we have answered the final question because we have found the dimensions of the garden. Let's look at another example. Each tile that Amy wants covers 3.5 square inches of space. She wants to cover 245 square inches in her bathroom with the tile. How many tiles will she need to purchase? Okay, let's think about this. The total amount of her bathroom is 345 square inches. Each little bitty tile covers 3.5 square inches. So how many tiles do we need to put in here? So I'm taking this entire amount and I'm dividing it into these little bitty amounts. So I know that the total area is 245 square inches. I know that each tile covers 3.5 square inches. So I want to divide the total area by the area covered by each tile. So I take the total area divided by the area per tile. So that's 245 inches squared divided by 3.5 square inches per tile. I set this up just like a complex fraction. We change it into an actual division. So I've got 245 divided by 3.5. Remember, when we're dividing fractions, we must change a mixed number into an improper fraction first by taking 3 times 2 plus 1, which will give me 7. So I now have 245 divided by 7 halves. Remember that while I'm dividing fractions, I flip my second one and change it to multiplication. So I now have 247 times 2 sevens. I can go ahead and take 247 divided by 7. That reduces my numbers, and that leaves me with 35 times 2. And 35 times 2 leaves me with 70 tiles. Therefore, it takes 70 tiles that cover 3.5 square inches to cover the entire bathroom floor of 245 square inches. Now, these are just two examples of problems that contain fractions in them. Any problem that we have could contain fractions. We just need to look at them and pay attention to what we're doing. Remember, if we're adding or subtracting, we must find a common denominator. If we're dividing, we must change it into multiplication. So please make sure that you're being careful of that. If you need any help, please let one of us know, and we'll be glad to help you.